Yo, what's good? What you guys saying? Back to the grind, man. Too much chilling for you lot. Carla, give me a chance, dude. 2 seconds in, where's Neil? What is this? Yo, Omar. Yo, Reno, what's up? Hassan, yo, Rayhan, Lung Gang, Ishak. My bad, bro. I thought you forgot. What? When have I ever missed a lesson? Maybe you wouldn't know. Always consistent. Samir with the talk Wi-Fi and that. What's up? What's good, G1? Duos, yo. How you doing, my man? I swear you want to be on the next lesson. At what? 1, isn't it? Something like that. Yo, Jenny. Lewis. Miram, what's up? Thundering, bro. What does that even mean? Where you at, dude? Shone's having breakfast. Mediterranean breakfast or an English breakfast? Priscilla, what's up? Nice, Finneker. It's gonna be lit. Aiden, Lungang, let's go. Aisha, morning. Tristan, yo, what's up, Carl? Part of the Lungang, officially, for real. I might just firm the workbook. Anurad, what's up? Welcome back. James, Lungang, nice. Zam, Lungang, Jayla, what's up? So, today, guys, binomial expansion. Now, you guys know from year 12 the choose method of doing things, right? But I'm going to show you guys how we can expand any type of bracket where the power doesn't necessarily have to be an integer. So something like this. Yeah, power half. I'm going to show you how you can do that at an elementary level. And obviously, when we do the full course, I'll show you guys a lot of cool things that we can do with this. But I'm going to give you guys an overview on how we can expand things like this. Yeah. Alright, say Nelly. Let's remind ourselves of year 12. Yeah. Make sure we know how to do this stuff. And then we can actually do the year 13 stuff. So in year 12, we were used to expanding terms in the form a plus bx to the power of n, where n was a natural number. But what happens when n is rational? We explored the formula. Well, if you study with me in year 12, I would have proved to you where the n choose r formula comes from. But we'll revisit this when we do binomial distributions. Now, we will need to use it more formally now, as our calculators cannot compute binomial coefficients when n is not a positive whole number. For example, when we do half choose 3, for example. Yeah? All right, so how would you guys expand 2 plus 3x to the power of 4? From year 12, let's just remind ourselves. How would we... I don't want anyone to say, write out 4 brackets, mate. There's no writing of 4 brackets. Not about that. How do you expand 2 plus 3x Pascal's triangle? Frank, is this Frank? Frank, your picture's changed. Is this Frank from my year 12 into the wedge man? Or is this another Frank? So yeah, we're going to... There you go. Omar and Zam, good. So we're going to do 4 choose 0. Now, do you guys find that very regularly you run out of space when you write across? So I write down. Yeah. Oh, different Frank. What's up, Frank? So you have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. If you guys want, you can write out Pascal's triangle, but you don't need to. Now, one of the coefficients, or one of the terms in the bracket is going to go down in power. So we usually like the power of x to go up and the constant term to go down. So it'll be 2 to the power of 4, 2 to the power of 3, 2 squared, 2 to the power of 1, and 2 to the power of 0. And then going the other way, yeah, going the other way, you have 3x, the other term. This one will be power 4, 3, dos, uno, 0. If you're going to type this in the calculator, you need to put this in a bracket. Maybe you don't even need a calculator. And another point I wanted to make is, you know, because what I find a lot of the time is you go down. Do you guys ever do this? You're doing 4, 3, 2, and then you'll go 3, 4 by accident. You go down and then you start going up because you didn't realize, well, because you're just used to counting up, innit? So what you should do when you double check, just make sure these all add up to what's here. So 1, 3, 4, 2, 2, 4, 3, 1, 4, and 4, 0, 4. Yeah, same thing. All right. Now you can type all that in one go in the calculator. I do it separately. 4 choose 0 is 1. 2 to the power 4 is 16. And we have 1 again. So we have 16. And then 4 choose 1 is 4. 2 cubed 8 times 3x. Can you guys tell me what that simplifies to? Something x. 4 choose 2 is 6. Yeah. Only 6 might. Thank you. 6 times quattro. Then here we have 3 squared, 9x squared. What does that give me? Something x squared. Michaela 216. Yo, Yanis, what are you telling me? You ready for this Thursday, my guy? And then next one, 4 choose 3 is gonna be 4 again. 2. 3 cubed is 27. X cubed. Then the last one, 1, 1, and 81. So close. You guys all just the 216 X cubed. Okay, so it's 216 again. Alright, cool. Alright, so there's our answer, right? So in year 12, this is how you would answer a question like this. Pretty simple, right? Don't get me wrong, like, binomial expansion year 13 is not difficult either. You just need to practice a lot. And it's easy to make mistakes, silly mistakes. Ataza, what's up? So, let me show you the binomial formula. But I like to prove things. Yeah, everything I do, guys, I like to prove it to you so it doesn't seem random. If you've already done this in year 12 going into year 13, most likely you've just been shown the formula. But I'm not that kind of teacher. So use the formula for n choose r to write out the coefficients n choose 0, n choose 1, n choose 2, n choose 3, generally for values of n. Justina, what's up? So remember, n choose r, trust me, is n factorial over r factorial. Yeah, so you see n on top, r on the bottom. Yes, that's how you remember it. Then times, you just subtract these. N minus r factorial. Yeah? Okay. So without doing anything, like any major simplification, guys, what would n choose 0 look like? Just by direct substitution, you don't need to simplify any exclamation marks. Just tell me what it would look like. Zakia, what? My dog was chewing my blanket. Your dog was reminding you that you had a lesson, that's why. So Omar, you don't have to do any major simplification, but you are right. Look at what Lewis has put. And Carla, yeah. Nice, guys. So we have n factorial over 0 factorial. Now here, I'm not gonna write n minus 0 as you guys have, but I did tell you to do that. For this, I'm gonna just write n factorial. Yeah. Now you can verify this in your calculator, but 0 factorial is 1. Yeah, you're basically saying how many different ways are there of arranging nothing? The answer is 1. There's nothing there. There's one way to arrange nothing, is to just leave it as it is. Yeah. Hey, birthday. Static, turning what, 15 or something, and then we have n factorial over n factorial, which just leaves us with 1. Okay, because these just cancel, don't they? All right, so n choose 0 is 1. Next one, n choose 1. This is where things start to get interesting. So what would it look like now? Now things are going to start getting interesting. So with the factorials, Kai, because we need to know how to simplify these things. In the exam, they can ask you to do these. Carlo, you're nearly there. Just the other way around. So remember, n goes first. So n is always the larger number. So it'd be n minus 1, right? All right, nice, guys. So we have n factorial over 1 factorial. And then n minus 1 factorial. Okay. Now, we all know, again, 1 factorial is just 1. Now, we need to know how to simplify things like this. N factorial over n minus 1 factorial. Now, in the chat, can you guys tell me, what do we mean by n factorial? Can you write the expansion of n factorial? Write me some terms of n factorial. What does it look like? Optimus, Carla, Emma, good. So we have n times the integers that precede it all the way down to 1. So we n times n minus 1, n minus 2, all the way down to 2 and 1. Yeah, we're talking about integers here. Yeah, all the way down to 2 and 1. All divided by, now what would n minus 1 factorial look like? What would n minus 1 factorial look like? Exactly, so it's the exact same thing, just starting from n minus 1. So after simplification, what are we left with? After simplification, what are we left with? Just n, good. These all cancel, we're left with n. So n choose 1 is n, yeah? Okay, let's just show it. N choose 2, so that'll be n factorial over 2 factorial, n minus 2 factorial, right? I'm just going to leave 2 factorial as it is, just because in the binomial formula, we like to keep it as a factorial. Can you guys tell me what n minus 2 factorial would be? How would you rewrite n minus 2 factorial? Why is n minus 2 factorial the same as? What do you mean, Jayla? N factorial just means 5 factorial is 5 times 4 times 3 times 2 times 1. So n factorial is n times n minus 1 times n minus 2, etc. You're multiplying by the terms that are 1 less than it. Okay, good. I don't know why I wrote n factorial, because I'm going to need to write its expansion. But yes, so we have n. You stop when you get to 1. So we have n minus 1, n minus 2, n minus 3. No, this is good enough. And then we've got n minus 2, which is n minus 2, n minus 3, all the way down to 1. Okay. Now, what do you notice this all simplifies to? Is on. That's the definition of a factorial. 5 factorial, 5, 4, 3, 2, 1. 4 factorial, 4, 3, 2, 1. They all end in 2 and 1. Okay, don't forget, guys, there is an n minus 1 on top as well. You're only cancelling from n minus 2. Yeah, so we have n minus 1 over 2 factorial. Yeah, the way I think of it here, guys, is there's 2 factorial. So we have 2 different things on the numerator, right? Here, this n is over 1 factorial. We just don't write it. There's 1 term on the numerator. Now, using that same idea, without doing any major expansions, can you tell me the result for n choose 3? Tell me this version for n choose 3. What would it look like? We don't expand the numerator, guys. We like to leave it like this, because otherwise you're not going to remember it. JMB, I see you, dude. Emma, good. Rohan, nice. Don't forget your factorial, though. Nice, guys. So, in the denominator, it's going to be 3 factorial, right? Because it's the third term. And like I just said, 3 factorial, yeah, is 3 terms on the numerator. It's n. We always start with n. Yeah, you can see it always starts with n. Then thinking about n factorial, the next term would be n minus 1. That's my second term. Then I need another one. That's the third term. There's 3 terms on the top. Yeah, so n choose 4 would be n, n minus 1, n minus 2, n minus 3, etc. Yeah, so these are our binomial coefficients generally. Yeah, these are our binomial coefficients generally. Now check this out. I can now write out a general binomial formula which can be applied to any rational power. Okay, so 1 plus x to the power of n. 1 plus x to the power of n. Now, because we don't know what n is, yeah, there could be an infinite number of terms. So remember, it starts like this. Let's write down a few terms. We have n choose 0, n choose 1, n choose 2, n choose 3. And it could keep going depending on what n is. Yeah. Then you're going to have 1 to the power of n. Now remember, this is going to go down, right? 1 to the power of n minus 1. So I'm going downwards. n minus 2, n minus 3, etc. Then we have the power of x. Yeah, then we have the power of x. Now remember, the power of x goes up. So it starts off with 0, then 1, then 2, then 3, etc. Yeah, and that could keep going. Now the cool thing about this, guys, is that 1 is just 1, right? We don't even need to worry about this. n choose 0 is 1, and this is 1. So this all gives me 1. Now, guys, can you tell me, what is this second line going to simplify to? We all know what n choose 1 is. Now simplify it. What does that second line simplify to? Nearly, Carla. So, guys, be careful. There's an n choose 1 there. So it's not just x. Not just x. N choose 1 is not 1. Amberjeet, good. Andy, good. So, guys, n choose 1, we just showed, is n. It's nx. nx. Xmas. Kaitan, what is this? Xmas. If that helps you remember it, sure. So, using that same idea, what would the second or third line simplify to? What does the third line simplify to? Be careful. Be careful. Yes is on. This allows us to compute any power now. There you go, Carla. Static, yep. We decided to write the n term first. So remember, it's n minus 1 over 2 factorial x squared. I think you guys have the hang of it now. So it's n minus 1, n minus 2 over 3 factorial x cubed. And this, guys, is the binomial formula. Yeah, this is 1 plus x power of n. I've run out of space up here, so let's write it here. 1 plus x power of n is 1. So it all starts off with 1 plus nx. n minus 1 over 2 factorial. It's very easy to remember. X squared. Then n minus 1, n minus 2 over 3 factorial x cubed. And then what we do is we write plus dot dot dot, because it depends how many terms we need here. If n was 4, if that n power was 4, then it would stop at x to the power of 4. So we can actually use this to expand anything. Yeah. Say, what if it was x plus 1 to the power of n? You switch the 1 and the x. Yeah. So if you ever see this, if we're doing a binomial expansion, we just swap it around. So the x term, guys, make sure it's second whenever we do these problems. And this, guys, is shown. Yeah, it's not an official proof, but it's me showing you how we can derive the formula. It's a derivation of formula. It's not proof of formula. They wouldn't ask this in the exam. But if I just showed you this formula, you guys would be like, what the hell, dude? No, Izan, we can expand anything. I'll show you. So, this is the binomial formula. This is the only formula we will use as it is consistent. Yeah, we cannot write a general formula for all cases. So, if you're like, wait, hold on, how do we do this then? Yeah, we're not going to derive a general formula for this. I'm going to show you how we can expand anything just using this. Yeah? So, how do we do that? What was I saying? The key here is that when n is a positive integer, when we keep subtracting 1, so guys, when we keep subtracting 1, eventually we'll get down to 0, right? So if n was 4, when we do n minus 4, we get 0. So that term just becomes 0, and everything after that becomes 0. So we can ignore it. However, if n is a negative number or a fraction, when we keep subtracting 1, that sequence is going to go on forever. Yeah, so actually, the binomial expansion where n is negative or a fraction, the sequence goes on forever. So the examiners will tell you how many terms they want. Yeah, because you can keep subtracting 1 forever. So, whenever we want to expand anything, guys, you need to make it look like this. So if I want to expand 1 over 1 minus x, that's an issue. What do you need to do with 1 over 1 minus x so that we can do the binomial expansion? What do we need to do first? And then it's easy. We can't split it, absolute, because there's 2 terms in the denominator. We can't split it. Keep it simple. Look at what I've circled. Emma, good. We bring up the denominator and we'll make it look. Nicholas, good. We make it look like what's above. Yeah, everything needs to be on one line. Okay, so let's take a look at what's going on here. Now, I recommend, guys, you keep writing this down. Well, as you read it, we're gonna substitute as we read. So I don't write down this formula every time. I read it in my head and I substitute as I go. So look at this. We can see that n, the n term, is minus 1. Yeah. What's different as well is x. We're not using x anymore. We're using minus x. Yeah. So that's the only difference. So wherever you see x, you're going to replace it with minus x. And wherever you see n, you're going to replace it with minus 1. But I'm going to show you. I don't write minus 1. You guys are smarter than that. You can say, write down what minus 1 is. Yeah. All right. So check this out. 1 minus x to the power of minus 1. So guys, it always starts off with 1 plus n x. Yeah. So you see, I'm reading it. So this is what I'll be doing in my head. Yeah. So I'm reading the formula, which I've written down many times. It's not a hard formula for you guys to remember either. But as I'm reading it, I'm substituting. Okay, listen. Plus n minus 1. I know how to subtract 1 from minus 1. Yeah. So n minus 1 over 2 factorial x squared. Yes, that's my second term. Yes, I've just done this one. Plus n minus 1. Minus 1 again is minus 3. Yeah, that's all we're doing. We're subtracting 1 every single time. Remember, we're just minusing 1 every single time. Yeah, so n minus 1, minus 1 again, over 3 factorial times x to the power of 3. Now look, I wanted first 4 terms. 1, 2, 3, 4. Now you can write plus ... to say, look, this sequence goes on forever. But they only wanted the first 4 terms. And now we simplify. Okay, very simple. 1. Minus 1 times minus x is plus x. Now you can type this in the calculator. but it's a very easy formula to simplify. The reason for that is the numerator here is 1 times 2, and the denominator is 1 times 2 as well, isn't it? They just cancel each other out. I'll show you guys how you can simplify this in the calculator really quickly. Yeah. So this all just simplifies to 1. Minus x squared is x squared. And same thing here. You know, you can type that all in the calculator. Let me show you now, actually, how you do that. You literally type it in as you see it. So we've got on the numerator minus 1, minus 2. But they are all going to cancel out to minus 1. So you have this 3. Now factorial for me is shift and then the x to the power of minus 1 over here. Okay, so you have that minus 1. So over here, what I do is above it, I'm going to write minus 1 times, then minus x cubed is minus x cubed. Yeah, because it's a triple negative. So be very careful. It's actually plus x cubed. Plus dot dot dot. And this is the expansion for 1 minus x to the minus 1. Now this, guys, is a very, very important formula that I want you guys to be aware of. You will memorize it in time. Don't worry about memorizing it now. It is the most basic binomial expansion. Yeah. 1 minus x to the power of minus 1 is just 1 plus x squared plus x cubed plus x power 4, x power 5, etc. They're all positive. Yeah. Another one that you need to know will be 1 plus x to the power of minus 1, and is very similar. Now the way you know how it's going to look is we know it's always going to start off with 1. But guys, remember the nx? That's the most important part to determine. That part, that gives you x, right? That came from multiplying these together. Yeah? That tells you the second term. So just by looking at that, what would the second term be? Exactly, J and B. So can you guys tell me what that second term would be? Using that same idea. Exactly, guys, it will. So in this case, yes, it will be minus x. So this one, guys, is an alternating sequence. It will go plus, minus, etc. So it's an alternating sequence. It's a minus x, man. Yes. Okay. So these two, guys, they're super important and very easy to remember. The most basic expansions for 1 minus x and 1 plus x to the power of minus 1. And the reason for that is they occur quite a lot in questions. And for 1 mark, you should just be able to quote them. Yeah? Alrighty then. Let's practice this skill again. Just make sure you guys remember these. So use the binomial expansion to find the first 4 terms of this. So what do we do first, Mike? What's always the first step here? ¿Qué pasa? Yo, Yusuf. Yo, why? Put on one line. Power minus 4. Good. All right. So 1 plus 3x to the power of minus 4. Okay. Now again, guys, listen to what I'm about to say. Yeah? No worries, devs. I got you guys. So, Yusuf. I'll see you later, dude. We have 1. Yeah, so guys, it always starts off with 1 plus n x. Yeah? nx. So I'm reading the formula in my mind and I'm writing down the numbers as I read it. So plus n minus 1. We all know how to subtract 1 from a number. All over 2 factorial x squared plus n minus 1 from that, minus 1 from that, over 3 factorial x cubed. And then it keeps going. And now we use the calculator to do everything for us. Apart from this, we all know what minus 4 times 3 is. Okay, now I recommend you all do this with me because I'm going to show you how you just type in everything, you know, quite quickly. So we have minus 4 minus 5 over 2 factorial. Now, to type in everything else, so can you see there's this 3x squared? What you do is you type that in the calculator without the x. So like this. There, you guys see that? I've literally typed in the exact same thing without the x. This will tell me the whole coefficient. I just need to add in the x squared again. So bang, 90. Yeah, so it's a plus 90. You have to remember to reintroduce the x squared. Now we have to do the x cubed. So all you do is you just go back and just change the squared to a cubed. You change 2 factorial into 3 factorial. Then you go into the numerator here and you add minus 6. So you can see how quick it is to just change it. Yeah, so you get minus 540. You just have to reintroduce the x cubed. You don't have to put ... if you don't want to. But that's it, guys. It's as simple as that. The binomial expansion. Omar, would they ever ask more than 4 terms? No. I've never seen an exam question for more than 4 terms. So in the exam, they might say 4 terms or they'll say up to x cubed. Yo, Lara. OG, bun cast. I think I taught the current students about bun cast. Have I told you guys about bun cast just yet? And Lara, did you see the video when I went to give Adelia the Vision Pros? Happy birthday, Lara. I swear I told you guys bun cast. Ayo, I showed you guys how to actually solve trig. So Lara knows. Good luck on Thursday, Lara. For real. Ayo, JMB, watch my streams last week on how to solve trig. Carl, it's one of my sayings, isn't it? Alright, so for the second question, guys, what are we gonna do? Bun cast. Yo, Sharif. Man like Algerian biscuit and that. Let's go. What are you saying, dude? Good luck for Thursday, my man. Hope the Algerian biscuits are keeping you satisfied. Power third. Power third, guys. There we go. Yeah. So cube root. All the OGs are coming back. All right. So again, guys, we start off with 1 plus n. Someone actually mentioned how to get the factorial on the CG50. So if you're using a CG50, can you instruct? I've not actually used the CG50 to get the factorial button. If you're using the CG50, can you put in the chat how to get the factorial button? It's probably to do with like catalog or something. Go to option. Oh, okay, something like that. Options, then probability, something like that. So 1 plus, trust me, Sharif, you got this. Where's Perrin? Just bunking. 1 plus n x plus n and then minus 1. So guys, let me show you a trick here. How do you subtract 1 from a fraction? You do the numerator minus the denominator. 1 minus 3 is minus 2. Then you just keep the denominator the same. Over 2 factorial. And then we have x squared. Okay, plus n minus 1. Minus 1 again. So guys, minus 2 minus 3 is minus 5. Over 3. Over 3 factorial. X cubed. Okay. And then again, guys, we just type all this in the calculator. So we have 1. We all know how to multiply these together. 2/3 x. All right. So again, guys, this practice in the calculator. So fraction 1/3 minus 2/3 2 factorial. Then again, you type this as you see it without the x term. Yeah? Minus 4/9. So minus 4/9 x squared. And then do the same thing. Change the squares into cubes. 2 factorial goes to 3 factorial. And then go to... Do you want the numerator here, guys? I do a double bracket before typing anything in. Otherwise, it can mess it up. So double bracket like this. Yeah, in the numerator. And then you do the fraction. It just protects it. Avoids any syntax errors. Boom. 40/81. Yeah. 40/81. X cubed. Plus ... Alrighty then. So guys, it's that simple for binomial expansions. Yo, Ibrahim. Which Ibrahim? I teach loads of Ibrahims. But what's up, dude? Hope life's good. Alright. Next question. Bun shoes. Now, what happens when the first number's not 1? Some of you guys were... Yo, Yanis. All the OGs come back with a bun cast. I'll convince all the New Year 13s. So, when the first number is not 1, as Ariana's just said, we just do a bit of factorizing. Yeah, so we factorize it so that it becomes number 1. Yeah. Oh, Ibrahim, the OG. What's up, dude? How are you? You went to Dubai, didn't you? Are you joining my class again? Is the question. How do we know whether to use this equation or n choose r? Afaf. N choose r is only if the power is a natural number. So 1, 2, 3, 4, 5, 6, 7. But everything else, you would use this. In year 13, you would pretty much only exclusively be using this anyway. Okay, so we all know that we're going to change this into power 1/2. Okay. Now, you guys haven't really looked at factorizing with the with powers. So naturally, you guys would be saying, okay, I want this to be 1, so I can use my formula. So I'm going to factorize out 4. Now, when you factorize out 4, yeah, you divide everything inside the bracket by 4, right? So it'll look like this. Is this correct in terms of factorizing with a power like this? Is this how it works? 0 said no. What? I assume no. True. Because that's, you got to square root it. Good, 0. So, when you factorize, guys, you have to make sure that the power is maintained. And this comes from something like this. Remember from GCSE. If you have AB to the power of n, it becomes A to the power of n, B to the power of n. Yeah? So, it's the same principle. You're factorizing. This is a process of factorizing. You have to distribute that power properly. So, it's 4 to the power of a half, which is actually 2, 1 minus a quarter x to the power of a half. And now we can do the same thing. Yeah, so let's take it. So we'll have 2. Now, this is what I do. I write a big bracket. I do a square bracket because square brackets just look better. And we're doing the same thing to this. Yeah, it's just the 2's on the outside. So let's do it together. 1 plus n x. Now, the x term here, guys, is minus a quarter x. So you can put a double bracket here. So n x, n minus 1. Now remember, guys, to minus 1, you do the numerator minus the denominator. 1 minus 2 is minus 1 over 2 factorial x squared. Then we have n n minus 1. Whoops, wrote that badly. Then you minus 1 again. So you're doing the numerator, minus 1, minus the denominator of 2. Minus 1 minus 2 is minus 3 over 2. All over 3 factorial. Minus a quarter x cubed. Okay. Now, keeping the 2 on the outside, we're going to type in everything else. So we get 1 minus, what's that? 1/8. I usually refrain from using the calculator for the first, the nx bit. So it's a lot of repetition for this stuff. But easy dubs in the exam. So just ignore the x. So minus 1 over 128. Can you guys type in the last term? Let's see if you guys can type things in properly. It's going to be a double. It's going to be a minus again. Can you guys type in that last term, something x cubed? You don't need that last term because it's up to x cubed. Huh? But that is an x cubed. What do you mean, Brev? Up to x cubed includes x cubed, yeah? Hey, yo, be careful, Brev. Frank, minus 1 over 1024. Lewis got the same. No, let's have a look. So change it to cubed. 2 factorial changes to 3 factorial. On the numerator, I do that double bracket first. Minus 3 over 2. Looks like you're all getting the same. Kiamon. Boom. All right. Now we just need to double everything. Because now we need to multiply in the 2, right? So we're going to get 2 minus 1/4 x minus, what is that? 1 over 64 x squared minus 1 over, what is that? 512, right? X cubed plus dot dot dot. Nice. Use this expansion with x is 0.1 to find an approximation for root of 390. Okay, so all this is a substitution, right? So what we've done is we've said this. Can you guys type in 0.1 into this? So we've literally found this out. So we've said 4 minus x, when you expand it, it's approximately all of this. Yeah? Okay, this gives you root 390 all over 10. So Finneker, remember not to put that 10 inside the root. The root protects the 390, right? Oh, I see what you've done, Finneker, actually, yeah. No, I mean, that's correct, but we want to keep it as root of 390, yeah? So when you put in x is 0.1 here, you're going to get root of 390 over 10. Calculator should tell you that. We're going to get approximately. Now we need to type in 0.1 into the right-hand side. Now, let me show you guys how to do that. The best way to do that is the storing function. So remember, I taught you how to do that last lesson. It avoids any mistakes. So we're going to do 2 minus 1/4 a minus 1 over 64 a squared minus 1 over 512 a cubed. All right, so let's all write this down. I see you guys are writing that. So 1.974841797. And then all you're doing, guys, is you're just timesing through by 10. So root 390 is approximately what? 19.74841797. We could test it. If we do root of 390, look at that. 7, 4, 8, 4, 1, 7, 6, 6. So there you go. It only changes by the last 2 digits. So the binomial expansion, guys, pretty close to accurate here. Yeah. My calculator doesn't tell me root 390 over 10. Does this matter? Root of 4 minus 0.1. Most likely you're typing power half. Guys, don't do this, because your calculator won't have a clue. You need to do root. Don't try and be clever, mate. Type it in as you see it. Alright. If not, you're going to have to reset your calculator by doing shift 9. And that, no, for the, well, yeah, for my one it's shift 9. For the graphical, I don't know how you reset it, but you would have to reset it, yeah? Okay. Next one. Expand 1 plus x minus 1 up to the x squared term. Now this guy should be very easy. Who remembers 1 plus x to the minus 1? Do we really need the a, or can we just put the power directly? What do you mean, Harlem? What does that mean? Afaf, it's in my calculator screen. It's the alternating one. Yes. What does that look like? Good. So it always starts off with 1. So it starts off with 1. So it's a 1, it's an x squared, but this one alternates in power, alternates in sign. So it'll be 1 minus x. So remember, you do that by multiplying these together. Then it'll become plus x squared. And that's it. Easiest 2 marks in the exam. Okay. Next one. Hence, write down the first 3 terms in this expansion. So guys, it's very close to being the same. What do you think the expansion of 1 plus bx would look like? Finneker, I see what you've written. See what the others think. So Lewis, what you've written with the bx all squared is technically correct, but without the bracket, what would it look like? So we don't want the bracket there. Okay, so we have to, the only thing we have to be careful of is it's not necessarily a b coefficient on every term. It's obviously going to be 1, yeah? If you apply my same concept, when you multiply those together, you get minus bx. However, this second term, guys, it's not just going to be bx squared, because remember, you're squaring that x term. You're squaring that bx term. So it's going to look like this, yeah? So by using your understanding of the basic expansions, the derivation of the formula, these questions here are really easy, yeah? No troubles, mate. No troubles. Part C, given that in the series expansion of 1 plus ax over 1 plus bx, the coefficient of x is minus 2, and the coefficient of x squared is 14, find a and b. So in the expansion, yo Hamza, of this, how would we expand 1 plus ax over 1 plus bx? Shristi, what calculator are you using? How would we expand 1 plus ax over 1 plus bx? Can't factorize anything there. Can't split it. Oh, you could, but that's long. Something easier. Cross on. Do something with a cross on. Maybe. Nice, Optimus. Bring up the denominator, make it a negative power. So it becomes 1 plus ax times 1 plus bx to the power of minus 1. Yeah? Shrusti, reset your calculator. And now we're talking about the expansion. Do we need to expand, or can both of these brackets be expanded? The answer is no. It can only be this one. Because 1 plus ax is just 1 plus ax, right? Now, when we expand 1 plus bx, up to which power should we write its expansion? Because obviously it goes on forever, right? Up to which term do we need to expand it? Zakir, good. The second, x squared, right? Because here they're talking about the coefficient of x squared. That's the largest power of x. So we just need to copy and paste what we wrote down in part B. Okay, that's all we need. Now what do we do? What's the next step? It will be simultaneous equations. Is on good. Partially expand. So you don't need to write down the whole expansion. Yeah? You don't need to write down the whole expansion. Are you using the root symbol, Shrusti? The coefficient of x is -2. So you only need to expand the terms that will give you an x term. So you have 1 times x. Yeah, so that's going to be minus bx. Minus bx. And nothing else with the 1. However, we have this is ax. So plus ax. Now, because I said the coefficient is -2, essentially I didn't need to write the x terms. I'm just going to cross them out. And I'm going to say this equals -2. So minus b plus a is -2. Okay. The coefficient of x squared is 14. So what you're basically learning from this, guys, is that you don't have to write the x term. Because we're saying the coefficient of x squared, I have 1 times b squared x squared. So in this case, it's just going to be b squared. Yeah, I'm not going to write x squared because we're just talking about the coefficient. And then we have ax times minus bx. That would become minus ab x squared, right? Which is going to make 14. So remember, I don't write the x squared term. Now, how do we solve this? So with this one, I'm going to write a minus b. How would you guys solve something like this? Substitution. Substitution. Is that what everyone would do? Making a the subject. So make a the subject and sub it in. Okay. I'm going to show you guys a trick here. And it generally works quite a lot with these binomial questions. Yo, Ryden, what are you telling me? Welcome back, dude. Look at this. What could you do with that first? Look at that expression on the left. B squared minus AB. You can do something like that. Good luck for Thursday, Ryden. Is on factorize. Yes. So when you factorize, guys, look. B minus A is 14. Do you notice anything there? Do you notice anything about that? Thursday's results day for the year 13s. Yeah, B minus A is 2. So guys, look at this. A minus B is -2. If you times through by -1, you get B minus A is 2. And by subbing that in, you get B straight away. Clever, right? So B is 7. The more you know, mate. The more you know. And to get A then, I guess we just sub it back into here, right? So A minus 7 is -2. So A is 5. And there you go. It's like a 4-mark question. 200 IQ play for real. Do we also get AS level results back? If you took your AS level exams, you get your results on Thursday. Yeah, it's all A level exams. Yes, it's Kahoot time, mate. It's Kahoot time. Come on. All right. What's up if you're watching on TikTok? Sorry, I'm on YouTube. I'm monitoring the chat on YouTube. All right. Oh, I have to log into Kahoot. It's Kahoot time. Time to show you guys how it's done, mate. Lesson 3, 5 questions. I'll put in the chat. I'll put the link in the chat. Hold on. Hey, yo, they got a new tune to Kahoot. Alright, let's see if you guys can beat me. I beat you guys last time, right? Pretty sure you guys are struggling, keep struggling to beat me. I'm in. Yeah. I lost last time. No, I didn't. I definitely won. I definitely won. The first lesson, I'm sure I won. Last Monday. Not having it, mate. Not having it. Alright, what are we saying, guys? You got 40 seconds to join. Aisha, in the description, check the number. Contact my team for the full course information. $20 seconds. Keep in mind, guys, for the full year 13 course, when we start in September, we won't have time for what's it? Kahoot, unfortunately. Nice one, boss. What's up? What's up? Alright, guys, let's go. Let me show you guys how it's done, mate. Let's see what the questions are saying. Hopefully, I won't need to use the calculator. Yes, it's on all on YouTube, but it's a private link. Convert that into degrees. Oh. Oh. Easy maths. Quick maths. 300. So remember, guys, it's 180 divided by 3 times 5. Yeah, so 180 divided by 3 times 5 gives you 300. All right. And that's crazy that Neil does trickery is first and I'm second. Surely I can take the win here. Who's Neil does trickery? That sounds like one of my OG students. Unbelievable. True or false? The first 3 terms of the binomial expansion are that. Oh, dude. What? How are you guys getting it so quick? I swear. What is true? Wait, what? N minus 2 times minus 3 times minus 4. What is that? What's 2, 3, 4 is 24 divided by... Wait, 2 times 3 is 6. 6 times 4 is 24. Divided by 3 factorial, which is 321. Wait, what? I swear that's wrong. Nah, I'm not having it, mate. What? 1 minus x. Ayo, Dom, I swear. So you have the middle. So the third term. Wait, what? Wait, which one am I looking at? Nah, am I bugging? Oh, that's the second term. No, that's the third term. Oh, no. Oh, I did the x cubed term. Nah, I'm tripping. For real. Wait, the x squared term would just be minus 2 minus 4. Which is 8. Minus 2 times minus 3. Nah, I'm bugging. Nah, that is right. Okay, ignore me, innit? Yo, I've just been thrown straight off the leaderboard, man. Oh, God. Alright, I'll catch up. It's all good, mate. It's all good. Solve. Okay, I was quick there, mate. I was quick. It's looking good. It's looking good. Alright, so I'm still in 9th place though. That's crazy. Okay, so when you do inverse sine of a half, you get pi over 6, which is the same as 30 degrees. Then you do pi minus your answer to get 5 pi over 6. That's how you get the secondary value, right? Yo. Yo, is that you or is that someone else? Celine up 19 places. Alright, question 4. I'm behind Zam. Alright, double points again. Which country does this flag belong to? So we don't always do, oh. Man like Dom likes to do a little flag question sometimes. Alright, so that one's Sri Lanka. Peak. Guys, that's so obvious, Sri Lanka. How did you guys not know that? Even I know that. I'm terrible with flags. Okay, I'm in 8th place though. Zam got it correct. But Neil does trickeries. Still on top. Yo, just got thrown off the leaderboard. Alright, last question. It's a slider question. In what year did humans first land on the moon? Oh, dude. I don't remember. I put an answer first, but I don't think it's right. I don't think it's right. Hey, are you guys all cheating? I already know you guys were Googling it. That's why there was such a delay. Bare cheaters. Oh, I got it right. Oh my God. 1979. I didn't know that was... No, wait. No, I got 1979 marks, but it was 1969. Hey, yo, that's kind of vibes, though. 1979 points. Oh, wait, so did I win? Oh, my days. I'm on the podium, though. No! That's so annoying. I was so close. Mate. Hey, yo, big Bamo, though. Hey, yo, respect. Where is this person? I've not seen that name in the chat. Bamo. Who's Big Bamo? But anyway, good. Oh, Ethan. Oh, okay, that makes sense. Bami Bade. That was Neil Does Trickery. Hey, yo, W's for Ethan then. Nice one. Guys, well done. Make sure you get the small homework done just for practice. And then next lesson, I think I introduced you guys to a bit of differentiation for year 13. So, well done, you lot. I'll see you all on Wednesday. Might have a nice couple of days. Good job, you lot. See y'all later. Peace out. Nice one. Nice. What's the homework, James? It's on the MindSpace platform. There is a link. There's a... What is it? A number in the description if you haven't got access yet. But I'll see you guys later. Peace out. Nice one.